Okay, very important slide. So this is a very updated, I took this figure from a very updated report about LNG. It's an updated report that is published few weeks ago or maybe few days ago, and I just received it by email. Is a report published by International Gas Union. I was in a conference in February in Oman, and this conference was organized by International Gas Union, okay, and IGR, IGU, and so this union is tracking all the information about natural gas, and you know that one of the biggest market of natural gas is LNG. Okay, so I'm gonna upload this report on you in D2L. It's a very updated report, and it has a lot of interesting information about LNG, and you will really enjoy it. So I'm gonna upload it on D2L, and then you can have access to it. So look at this. This side is the main players, main exporter of LNG in the world, and this is showing where their LNG is exported to. And in this side, on the right, you have the countries that are buying, that are receiving our LNG. Okay, so the four main players: Qatar, Australia, Russia, and US. Okay, where is Qatar? First place, first ranking, with the amount of 77.8 megaton of LNG in 2019. Okay, so among the world countries, among the whole LNG exporters. So those are not the only LNG exporters. There are some other countries that are also exporting LNG, but Qatar is the main player in this field. Okay, it's even more than Australia and any other country in the world. So this shows how this industry is critical to our economy and how important it is in terms of the development of the country, in terms of economical development and any other type of development. So this is just an introduction slide to show you how important is this course for you to learn. Maybe you know, like, that means this figure, this number here means that we have a lot of job opportunities. The market is very huge in Qatar. So if you learn this course carefully, I mean, in a very good way, so then who knows, maybe in future you might be hired in one of these LNG related industries in Qatar or anywhere else. So please take it seriously. Okay, so after this presentation, I expect that you know what is the LNG properties. When we are talking about the LNG properties, some major units in LNG system, we have at least 1-2 figures about the major units. Describe the specification, LNG product specification, in terms of combustion characteristic, moisture content or water content, residual mercaptan. Mercaptans are molecules that we show it in general in this way: RSH. S is sulfur, H is hydrogen, R is any molecule that has carbon and hydrogen, like CHS, okay, or C2H5, okay, any hydrocarbon that contains carbon. Sulfur compounds can be, let's say, other compounds, H2S for example, mercury, and caloric value. Okay, LNG. What is LNG and its properties? LNG is a liquefied natural gas. The natural gas in the liquid form. It's a mixture of hydrocarbons mainly methane. The main component of LNG or natural gas is methane, CH4. It's a non-toxic and non-corrosive material, is colorless and odorless. So it doesn't have any color and it doesn't have any smell. Once it is spread on the land or water, it doesn't leave any residue. It will be vaporized to the atmosphere. This is another property. It has a boiling point, as I remember, about 162 or I think the boiling point of LNG is about minus 162 degrees C. At this, below this temperature, it will be liquid, in the liquid form. So this is just one additional piece of information for you. And above minus 107, above 100 minus 7, it is lighter than air. Okay, so it means in the atmospheric temperature, which is 23 degrees C, let's say the average, the ambient temperature, it will be much lighter than air. Lighter means less density than air. All right, so it means it can goes up in the air very rapidly. So it's very flammable. Is not explosive, but is flammable. It can catch fire. It doesn't explode, but it can catch fire at very small volume. Let's say if you have a container that has between 5 to 15% of LNG, 5 to 15% of the volume of the container is LNG, it can easily catch fire. It's not explosive unless if it's ignited in closed space. If it's ignited in closed space, it can be explosive. But it's not like TNT that can explode even in the solid form, right? Okay. LNG is maintained at a very low temperature. As I said, the boiling temperature is minus 162. It's kept at very low temperature, and that's why it's very dangerous if you touch it. Let's say if you have an LNG or the container, since it's at a very low temperature, so it's very dangerous to contact with. So these two slides are the properties of LNG. Now, why we have to liquefy natural gas? Why we have to create LNG? The first and main important reason is the lower volume. When you have, let's say, 1 kilogram of natural gas in the gas form, when you convert this 1 kilogram of natural gas to the liquid form, you decrease the volume of natural gas by 600 times. So 1 kilogram of natural gas in the gas form needs a volume 600 times more than if the gas is in liquid form. So that means if we liquefied it, we need much less volume. So that means we can transport it and store it in the easier way. And then what? Okay, so let's say if we have a pipeline, gas pipeline that is supplying gas for us, sometimes let's say during winter in some cold countries, during the winter the heating demand is higher, so we need to add more and more gas to the pipeline. So if we have LNG storage somewhere, we can merge it with this gas pipeline and add more gas to be able to satisfy the demand. Or sometimes in the peak, like let's say some some hours in the day that all the restaurants are working, all the companies are open, offices are open, so we consume more natural gas than other hours. So those peak periods, we need more gas that we can inject to the pipeline by using LNG. And there are, Qatar is a country in the Middle East, and and has a lot of natural gas. We cannot export all this natural gas by using pipeline to many other countries. Maybe it's possible to export it to neighbor countries, but let's say if you are going to export natural gas from Qatar to Europe, okay, or to Asian countries, we cannot do it with pipeline. We need a lot. It's not possible. This is impossible to do. So by having LNG, converting natural gas to liquid phase, we can send the gas anywhere that we want beyond the pipeline boundaries. Okay, so we have different products or petroleum products. So let's say kerosene, which is a very heavy oil. Gasoline is light oil, light crude oil. Naphtha is even lighter than gasoline. Is, let's say, jet fuel and some other chemicals. We have also LPG, which is liquid petroleum gas. Liquid petroleum. So the crude oil has different fractions that some of them can be liquefied easily. Okay, like that has between 3 to 4 carbons. We have also NGL, natural gas liquids, and we have LNG. So this line here shows how the molecular weight is sorted. Okay, in terms of molecular weight, where they are located. LNG is the lightest. It's the lightest product, or how can I say, hydrocarbon products, has the lowest molecular weight, and then we have NGL, LPG, naphtha, gasoline, and kerosene. Kerosene is, let's say, bitumen or some material that we use for let's say road construction, asphalt. So LNG, the main component in LNG is from C1 to C4. Then we have NGL, natural gas liquid, that has mainly C2 to C5 plus C5. LPG is mainly C3 to C4. Naphtha is C5 to C7. Gasoline C7 to C11, C8 to C11, and finally kerosene, as you see, is a very, very large molecule with between 12 to 15 carbon atoms. Okay, so LNG is the lightest, that has between C1 to C4. Methane, ethane, butane, propane, and butane. C4. Okay, natural gas that has is majority form of methane. The main component in natural gas or LNG is methane. Is a greenhouse gas. Is a gas that has a lot of bad effect on the planet, on the atmosphere. Okay, and it has a very high global warming potential, or they also call it GWP, global warming potential. It is the global warming potential of natural gas or methane is approximately 4 times more than the carbon dioxide. We always talk about carbon dioxide, but there are components like methane that are that we have. We have a lot of methane resources, like natural gas resources, that are more dangerous to the atmosphere. Okay, the GWP is 4 times more than methane. Okay, However, okay, the C over H ratio in the natural gas, since it has only methane, C over H ratio is lower than gasoline or crude oil. Okay, so the CH ratio in methane or natural gas is less than this ratio in gasoline. So when it is burned, that it produces CO2, so its CO2 emission will be also lower, about 22 to 25% lower than gasoline. So the CO2 emission of natural gas is about 54 compared to the CO2 emission of gasoline, which is 71. So this is about 22 to 25% less than gasoline. So that's why natural gas as a fuel is cleaner than gasoline. Okay? Because when you burn it, it doesn't produce a lot of CO2. I mean, comparing it produce, but comparing with gasoline, no. How much? 54 gram of CO2 per each megajoule of natural gas that is burned. Okay. Liquid hydrocarbon like petroleum or gasoline, the gas that we use in our car. So this is before I explain. So before I explain this paragraph, so combustion of methane is different from that of liquid hydrocarbon combustion. Okay, so the reason is that in liquid hydrocarbon like gasoline, petroleum, we have different carbon hydrogen bands. We can have double bands. We can have double carbon bands. Okay, we can have let's say, I mean, we can have different carbon hydrogen or carbon bands in gasoline. Okay, but in natural gas we have mainly majority of molecules is methane that has only one single carbon that has like 4 single carbon hydrogen bonds. Okay, so it's different from hydrocarbon liquid that can have different type of bonds. Even in liquid hydrocarbon, we have double band, single band. Okay, we can have double band, but majority is again single band. So, but in natural gas we don't have even the single band of carbon. Okay, since there is no single carbon band involved. Okay. So since we don't have carbon bands, the combustion of natural gas is more likely to be completed. So we will have really a complete complete combustion, and the combustion product is majority water and carbon dioxide. So it doesn't produce any non-methane hydrocarbon after combustion. Okay, again, that here we study some of the advantage. This is also the continuing advantage of natural gas. Particulate emission are very low related to the diesel fuel. So when we burn the natural gas, we don't produce any kind of smoke, or let's say coke formation. There is no smoke, so it's very clean fuel. So the flame temperature, adiabatic flame temperature for natural gas is about 2240 Kelvin, which is less than that temperature for gasoline flame, which is 2310 Kelvin. Okay, so the flame temperature is lower, this is another advantage. The equipment that is going to burn this gas need less thermal resistance, so it will be less costly for us. This is the first thing. Then if we can have a flame at lower temperature, this is advantageous. It's a good advantage for many applications, since, you know, in terms of safety, hazard, this kind of things. And the reason is that when the natural gas is burned, it produces water. This water content will keep the flame temperature lower, and it also gives us lower NOx molecules. Okay, and also it will operate. Okay, if we operate under lean condition, so I mean natural gas, lean natural gas, we will have also lower peak combustion temperature with lower NOx molecules. Okay, why? Okay, we already talk about why we have to liquefy gas to produce LNG. We already talked about this, but the natural gas that is coming out of reservoir is not only methane. It has a lot of unwanted, undesired components that we have to separate it. And depending to which area, which country we are sending this LNG, that country has a specific requirement. Okay, so we have to treat our natural gas and convert it to LNG and then ship it or send it to the receiving country. So why we need to treat first? To obtain the specification requested. Okay, to protect the equipments. Many equipments are sensitive to, you know, like corrosive components like steel, metals. We have to protect them. Environmental reason. Now these days environmental regulations are very strict. We have to follow them. We have to meet them. Otherwise we cannot be in the market. Okay. Again, whoever is receiving your LNG, okay, then it will process that LNG. It will send it to the equipment. Different equipments to be used for different reasons. So this equipment, the type of this equipment or the process that is using the LNG, it really depends to the LNG pre-treatment. Okay, so which type of treatment has been done before. They have to check which type of treatment is needed before sending to that process, and for sure cost will vary. So if you have a dirty natural gas, sour natural gas, or sweet natural gas, they have different price. So you have to see how much money you have to put to clean that gas, treat that gas, and then send it. And then you will see which one is more affordable for you. So this is an overall diagram for LNG processing. So we have most of our gas fields are in the sea, so it's offshore. So we have those gas stations that we will extract the gas from the sea. We send it to onshore. We send it to the land. In the land, we have a sequence of equipments. First of all, we have equipment like a sludge catcher. That because this natural gas that is coming from underground, it comes with a sludge, it comes with mold, it comes with water. So we have to separate that. So we have to separate the water, sludge, and some other impurities that can be easily separated based on their gravity or density. We can have also some condensate here, some heavy molecules, heavy hydrocarbon molecules. Then we have almost a raw natural gas free of solid or sludge. We will send it to several purification and treatment processes, and we will talk about this a little bit later. And then we liquefied it, we cooled it down, we liquefied it. So when we liquefy the gas, we will also remove some heavy hydrocarbons. because LNG is mainly methane, so we will try to remove as much as possible any heavier molecules than methane, like ethane, propane, butane, and so on. Then we have a storage tank. Is usually big storage tanks, spherical ones, that we will store the LNG in those tanks. Okay, those tanks have also very excellent isolation, not to lose or receive heat. Then after that, once we storage those LNG methanes, we will have some pumps to send it to ship it, to load it. There are ships that are very specifically designed ship for LNG with those. You might have seen some photos of these ships, or maybe you have even seen in some videos. Then once it's loaded, it will be transported, and then once it's received to the receiving country, it will be unloaded again, it will be stored. Then there is a regasification, that they have to heat it to convert it from liquid phase to gas phase, and then is natural gas in gas phase that will be sent to the gas network or wherever it's supposed to be used. This is the cycle, the overall diagram or cycle of LNG. So there are several steps in treating the natural gas, the LNG. Okay, so I'm gonna go briefly in this. Explain them in this slide. So we have raw natural gas. We have to remove the mercury. Mercury is one of the impurities. Then we have to remove acid gas. If you remember, we had in PO 2410, we had amine acid removal, that we had to remove, let's say, CO2 and H2S. Those are acid gas. Then we have to remove, we have dehydration, that we also talk about those process in PO 2410. So now you can see why we had to learn those equipments. So we have dehydration, that we will remove water, and some mercaptans that are sulfur contain components. After that, again, we will have another step of mercury removal, and then we will send it to natural gas and liquid recoveries, some heavy molecules, and chilling. So then we will send it to liquefaction process, okay, to liquefy the natural gas in this part here. After that, we will remove helium. The natural gas has usually some helium components. We have to remove it, and also most of the time it contains nitrogen, that we have to remove the nitrogen. And after that, we will have the LNG, which is proper for storage and shipping. What we will do with that helium, so we will purify that helium. If the helium from this line comes with some other impurities, we will purify it, and then we sell it, or we will use it in any step in the process that is needed. So here, okay, with the acid gas enrichment, so we will remove H2S in this process. So we have to again enrich the acid gas, make sure there is no impurities. Then we will send it to some process to remove the sulfur compound S, because S has some values. Sulfur can be used in many processes for many applications. So we can produce sulfur, store that sulfur, and then sell it or use it for any other application that is needed. And okay, here we will recover then liquid gas, natural gas liquids, and mercaptans, or heavy molecules. Then we will have some fractionation, I mean, we will separate C1 from C2 from C3, C4, okay, and we will have several steps here to separate butane, ethane, butane, ethane, propane, and butane from each other. And at the end, we will have our LPG, okay, liquid petroleum gas, that will be stored, which is heavy molecules, I mean heavier than methane, like C2, C3. And also, yeah, those trains here, those steps are all interacting with some other steps in the liquefaction and in the chilling process, so that to remove the remaining components C2, C3, and C4 from natural gas and having our LPG. So this is the overall diagram of how is a LNG train, okay, and how we treat our natural gas and produce and clean it and produce LNG. We're gonna talk about these steps in other units. Okay, let's say about acid gas removal, dehydration, and so on. Okay, the quality of LNG is defined based on different parameters. There are different parameters that is used to define the quality of LNG. One of them is the caloric value. Okay, one of them is the caloric value. How much is the energy value of the natural of the LNG? Okay, how much is the heating value or the energy value? So this is caloric value or heating value is one of the one of the criteria to evaluate the quality of LNG, caloric value. Or we also call it heating value or HHV, heating value or HHV. And some markets, or in some markets or some countries, they also use gross calorific value, GCV. So what is this? Is the energy content per volume of natural gas in the gas phase. Energy content of the natural gas, energy content per volume of natural gas. Let's say megajoule per cubic meter, something like that, or megajoule per liter of natural gas at a standard temperature and pressure when it is burned completely in dry air. So how we find the caloric value or heating value? If, let's say, we burn 1 cubic meter of natural gas at a standard temperature and pressure with dry air. Why we use dry air? Because air is the source of our oxygen. So if we burn it in dry air completely, convert it to convert all the natural gas to the product, then and how much heat it will produce, that will be the heating value. So this, okay, in heating value we will also consider the energy that we need to put to bring all the gas products of the combustion to the same standard condition of temperature and pressure, and water has to be condensed to liquid phase. Okay, so when we have this combustion reaction, we will produce some heat. Then we have to to find the heating value, we have to also consider the amount of energy that we need to put to bring the gas product to the standard condition, and also the water, which is one of the combustion product. We have to convert it. We have to keep it in the liquid phase, bring it to the liquid phase. So then we have to consider those energies that is needed for this work in calculating the heating value. Okay. But okay, caloric value or heating value is a good parameter to evaluate the quality of the gas, but is not a sufficient value. It's not enough, because two gas with the same heating value can be very different. Okay, because we can have two different gas that have the same heating value. So heating value is not a unique identity for a gas. Okay, we need something more specific, more unique. So whoever receiving your gas, your LNG, it will care about these two things: the combustion properties, okay, that I mean, because like they usually burn that gas, use it in the heating devices for the energy. So the operation of that burner, gas burner, is very important. So they will care about the combustion properties. Okay, that is usually described by interchangeability parameter. And also when the user, the customer that receives your gas, it really care about the level of impurities in your gas, because this is very important for the safety, for the environment, and the performance of the chemical plant that is receiving your gas as a feedstock. Okay, so your customer take care about these two things. Okay, heating value, HHV, although is a good parameter to evaluate the quality of the gas, but as I said, is not enough and is not really is not unique. So we need to use another parameter or another index or another indicator. That Wobbe number, or they call it also Wobbe Index, is one of those unique parameters that is used to evaluate the combustion characteristic of natural gas. Okay, it's a very important parameter to evaluate the combustion performance of natural gas. Okay, so it has more meaning than the heating value. Wobbe number or Wobbe index, we show it with WI, okay, which is the heating value divided by a specific gravity. The heating value, a specific gravity, power 0.5. So this specific gravity, it makes it a bit more specific for the gas. For more specific parameter for my gas. Why? Because two different gas might have the same heating value, but since there are different gases, different molecules, they don't have necessarily the specific gravity. All right. So this is the why this parameter is more interesting. It also considers the flow and heat inputs. Okay, so how it's calculated is like accounts for the flow and heat input of a gas through an orifice. Specific gravity is a transportation or transport properties. So this parameter considers both the flow and heat value, the flow properties or transport properties, and the heat, because at the end the gas will go through an orifice to be burned to create the flame or energy. Okay, some additional information about the Wobbe index, or in general the combustion properties. So if we have two gas that have the same Wobbe index, then the energy that is put to the flame of the burner is the same in the given pressure. If the flame temperature, the burning or combustion pressure is the same, and the two gas they have the same Wobbe index, then the energy that they are producing okay, the energy that they are producing, they are giving in the flame is the same. Wobbe index, if you see in the previous slide, is energy divided by a specific gravity. Okay, so heating value, if you remember, is the amount of heat per volume. Let's say megajoule per volume. Okay, megajoule per cubic meter. The specific gravity doesn't have any unit. Okay, is a dimensionless number, unitless. Okay, so the Wobbe index have the same. This is a dimensionless number, specific gravity. So Wobbe index has the same unit as heating value, megajoule per cubic meter. Okay, so it can be megajoule per cubic meter or BTU per square cubic foot, standard cubic foot, SCF, standard cubic foot. Okay. When we are, the combustion properties also define the amount of pollutant components like NOx or emissions that we will produce by burning the natural gas. If we put a lower and upper limit for our VI, Wobbe index, that we are, if we put a lower and upper bound for our Wobbe index for the gas that we are receiving, so then we can control the amount of emission, the amount of NOx and emission, and we can have, by controlling the VI Wobbe index, we can have also a very high efficiency of burner and also a very safe operation of equipment. So adjusting or having a limit for Wobbe index is very important in terms of controlling the emissions, having a good efficiency of the burner or combustion vessel or equipment, and also a safe operation of the equipment. Okay, so for many, we talk about the interchangeability parameters. One of them is the Wobbe number, let's say megajoule per cubic meter, and let's say the non-methane, the percentage of non-methane in LNG, non-methane component in LNG. So as I said, LNG can have, its majority is natural gas methane, but if we mix this methane with some non-methane components like nitrogen, then we can change the properties of the combustion properties of my LNG or natural gas. So we have such a graphs that shows the acceptable operating condition for our natural gas. This is the things that most of the countries they follow. So the acceptable range for the natural gas is this area. Below it is emergency situation, above it is emergency situation. So in this area, if my Wobbe number is in this limit, this is the lower limit, this is the upper limit, and the amount of component, the percentage of components is in this range, non-methane components in this range, then I will have an acceptable combustion. Above it, if I am here, is incomplete combustion. Here is sooting. Sooting is creating a smoke, creating, let's say, coke-like molecules, smoke. And below it we have flame lift. Okay, a large flame or a very tall flame, which is not good for the operation. So many countries they follow such a graph to to adjust the properties of LNG to be in this range. So I will talk a little bit more in the next slide. So this constraint is based on the performance of domestic appliances. Let's say the oven that we have in the kitchen or in the restaurant, so they work in this range. Or some old appliances. We have a large population of old appliances that we are using for many years. Okay. For example, UK government is very strict about these things. So they are trying to have new policies by just evaluating the existing issues that they have. And also incomplete combustion can produce carbon monoxide, which is a very poisoning molecule and very dangerous molecule, and can even kill. Okay, so how we can stay in this area that I already talked about. So for UK, the LNG that, let's say, the UK is receiving from Qatar, it will be in this area, this blue line. It has to bring this blue line to somewhere here, acceptable range. Here you can see that if we add nitrogen, let's say 2% or 4% nitrogen to our LNG, then our operation will be in the acceptable range, like this one here. Okay, so you see that LNG, a pure LNG, has a very high Wobbe number and the Wobbe Index, very high heating value. Once we add a little bit nitrogen, we can make it a bit lean. Okay, we can make it a bit less, we can reduce its heating value and we can keep it in the acceptable operating range. So most of the LNG that is received by UK based on UK market is a very rich, is richer than what they need. Okay, so they have to mix it with some other components like inert gas, nitrogen, to bring it to the acceptable range. So ballasting with nitrogen, bring it to required specification. Okay, impurities, there are various type of impurities that I will show you in the next slide. So before we send the natural gas to liquefaction process or liquefaction step, because cool it down, we need to extract the impurities. The main impurities is mercury, that will really damage the cryogenic equipment. Cryogenic equipments are those equipments that are mainly for cooling process, refrigeration process. Mercury will really damage them. Water and CO2. Okay, there are also the impurities in natural gas. Water and CO2, they will flare, and so we have to remove them, right? There are also other impurities that you can see in this slide. So carbon dioxide, H2S, mercaptans, as I said, we show it with R, are those hydrocarbon molecules that they contain sulfur components. R, S, H. R can be any hydrocarbon. Carbonyl sulfide, COS, is also an impurity. Carbon sulfide, CS2, is also an impurity. Water, and finally mercury. So how much of this components or impurities is allowed in natural gas or LNG? How much of them is required? or what is the maximum amount of these things in our natural gas, this will be defined by our customer. Okay, the customer use this natural gas in some equipment, some downstream equipments, and also during the purifying the natural gas, treating the natural gas, let's say before I send the natural gas to LNG, to liquefaction process, liquefaction refrigeration step, I have to remove mercury. Okay, so the amount of this the degree of removal of this component and how to remove them, the sequence to remove them, it really depends on the downstream equipment. Okay, we have to follow this limits. The amount of CO2 has to be below 100 ppm, volumetric ppm. The reason is that it can freeze and cause equipment plugging. H2S should be below 4 ppm. So this is the gas that the sale specification. When we are going to sell it, we need this much H2S. Total sulfur, including mercaptans. Total sulfur, it means this sulfur here. SOS, COS, CS2 plus mercaptan, all these three. This total sulfur included here in these three components, and also in H2S here. 1, 2, 3, 4. We have 4 sources of sulfur. The total amount of sulfur in the natural gas has to be below 20 ppm, volumetric ppm, and water, since it freezes and it can create plugging, it has to be very low, the amount of water 0.1, and mercury also below 0.01 microgram per normal cubic meter. Okay, the reason is that it can create corrosion, especially in aluminium exchange. Okay, so we have to we are very strict about mercury, and we have to really remove it carefully. Okay, nitrogen. So there are economic reasons that that really force the exporter like Qatar to limit the amount of nitrogen in the LNG that is exported. First of all, LNG is very hard to liquefy. Okay, the boiling temperature is the condensing temperature is very low. Okay, the boiling temperature is very low, so it's very hard to liquefy, and also it doesn't have any value. Okay, the inert gas, it doesn't have any value, and when you put it in the cargo, you just shipping useless or some component, some material that doesn't have any value. You're just paying for the shipment, right? And also, and we have to try to remove it as much as possible, although the liquefaction is hard. But except, as I said, in UK, they don't really need a pure LNG, right? If our customer is UK, so we don't need to be really worried about the amount of nitrogen, because they don't need really pure and rich LNG. They need some nitrogen in their LNG. Okay, so depending to their customer, it will be also you can, you have more flexibility depending to your customer. Then another issue with nitrogen is that it creates boil off in the shipping. It creates a vapor, high pressure vapor. So that's why it makes it makes the handling the equipment harder. Equipments, cannot handle very high pressure. So the shipping, the value of nitrogen for the ship loading is about 0.5 mole percent. Okay, 0.5 mole percent let's say if you have 100 mole of LNG, not more than 0.5% can be nitrogen. So it will be always removed to a level of 0.5 to 1 mole percent. Okay, and when we remove the nitrogen at the end, in the end flash or a nitrogen rejection unit, okay, in the cold end of the liquefaction process. So at the end of the liquefaction process, we will have a end flash for nitrogen rejection. Oxygen, usually we don't have a big amount of oxygen in nitrogen in the natural gas, okay, and except in some cases it is introduced, artificially. It means, let's say when we have the reservoir, the natural gas coming from reservoir and it contain water, we might have some dissolved oxygen in that water. So that oxygen might be transferred to natural gas. Except that, in general, the natural gas doesn't contain oxygen naturally. Okay, and the problem with oxygen is that even a small amount of oxygen in LNG plant, export plant, it can cause corrosion. Okay. Especially if we have, let's say, when we are going to treat the oxygen, okay, when we are going to treat our natural gas, so if the natural gas has some oxygen in the amine treating unit. Amine treating unit is a unit that we will remove the acid gas like CO2 and H2S. This oxygen in that unit can cause corrosion. Okay, so we have to be very careful about that. And okay, it's very, so the LNG exporters, they will really, they will be really careful to put a limit on this. Okay, whoever receiving or exporting the LNG, so they have to keep the amount of oxygen to minimum. The reason is that it can create corrosion in the amine treating process. Sulfur also, as I said, it can be in the form of H2S, hydrogen sulfide, COS, carbon sulfide, mercaptans, and generally we call it total, and also CS2, okay, and generally total sulfur. Okay. Sulfur is also very limited. The amount of sulfur is very limited in the contracts, sale contracts, and the reason is the environmental issues. That in future, the legislation, for environmental legislations are being really stricter, and they will, put a lot. They are going to, because H2S or sulfur like SO2. Sulfur contained molecules that are very dangerous to the environment. They are producing a lot of greenhouse effects. So the future environmental legislations are very strict about the amount of sulfur in LNG, and especially in Middle East, that we have many sour fields. Sour field means our natural gas contains a big amount of CO, so for us it will be a bit more challenging to control the amount of sulfur in LNG. Then, okay, some more details about the sulfur, the amount of sulfur in natural gas. So H2S or hydrogen sulfide is one of the impurities in natural gas in LNG. It's a highly corrosive, okay, especially in presence of water. If you have water content, H2S can react with water, and these two together can be very corrosive, okay, and And this is very problematic. Let's say when a country, your customer, receive your LNG, it has to regasify the LNG and send it to the pipeline. And most of the pipeline, they have a high amount of water content. So if your LNG contain H2S, it can react with that water content in the pipeline, and it can create a big amount of big corrosive. It can make a lot of corrosive problem. Okay. So typical limit for H2S is between 5 to 7 milligram per cubic meter. Okay. But it depends again to the country. Like let's say the report that is Japan, for example, is moving to a very tighter specification, and they really need less amount of H2S in the LNG that are receiving from the sellers, from the exporters. Okay? And the reason is that they are using natural gas or methane in fuel cells to produce electricity. Okay, they are using natural gas in fuel cells to produce electricity, or even these days they are producing hydrogen by using methane. And those fuel cells are very, like sensitive to H2S poisoning. In Europe, EASEE gas, I will tell you what is this word for. I mean, what's the definition of this word? Is a union, is an association in Europe that they control the natural gas, like market. So they put the limitation of 4.74 milligram of sulfur per each cubic meter of LNG that they are receiving. Okay, so European Union, they have this limit. Usually between 5 to 7 is acceptable, but again, depending to the region, to the country, they have different legislations. Mercaptans, that also, as I said, there are RSH molecules like that they contain sulfur. So they are less dangerous, okay, but they are smelly, okay. And they are smelly, and that's why they are less dangerous. I mean, they are less sensitivity regarding mercaptans. Since they are smelly, they are used usually for leakage detection. In many distribution companies, they use for the leakage detection, and they are less dangerous. Since they are not that dangerous, so it's okay to use it for leakage detection. And if there is any limitation for mercaptans, is really because of environmental issue. But it has sulfur that is dangerous for environmental. So, and most of the sulfur content in the natural gas will be in the form of mercaptans. Okay. Okay. So, in general, one additional piece of information is that, yes, we know that we always want, let's say, a very limited amount of these impurities in our natural gas, in our LNG, but we have to take into consideration that changing any of this limitation, removing any of these impurities to the lowest possible to the lowest possible amount, that means more separation, more expenses, more work, right? So those are the things that the exporters will always take into account. Okay. EASEE is European Association for Streamlining of Energy Exchange. Okay. European Association for Streamlining of Energy Exchange. The union is an association that controls this market. So they have proposed, okay, to put a limit of total sulfur in the gas imported from any country to EU, European Union, to be 20 8 milligram per cubic meter. So the total amount of sulfur in the natural gas in the LNG imported to EU should not exceed 28.42 milligram per cubic meter. And however, they put some limitation for the amount of mercaptan itself, which is less than 5.69. okay, so here, they proposed to even bring it down. It's like this, to bring it to 4.74, but the current limit for mercaptan is 5.69 milligram per cubic meter. As I said, they are proposing to even bring it lower. That still is very difficult for some exporter to reach to this level, okay? Because as I said, removing these components, impurities, means more cost, less benefit. Okay, so this table shows some limitation exposed by different countries for the LNG that are receiving. It's very nice table that is summarizing all this information. So here you have the specification, the hydrogen sulfide, H2S, total sulfide, the sulfur from mercaptan, carbon dioxide, oxygen, water, and so on. Here it shows this number either is a maximum or minimum. In this table, mainly the maximum. This is the maximum amount that they can receive. Except the two last one, which is a gross calorimetric value. Okay, that should be minimum, because the amount of heating value should be the minimum that they want is those values. So you can see that, okay, here you have the units, and here you can see that different countries, let's say France, Italy, UK, Canada, US, Japan, they have different limitations, but they are very, the limitations are not very far from each other, but most of the cases. But for example, for carbon dioxide, as you can see, is in the order of 3 to 2 volume percent. I don't know, caloric value is a bit different. Yeah, like the total sulfur is a bit different. Like Italy has a very high upper band. Even Canada is the highest between them. Japan is very strict, between 8 to 30. So you see, depending to your customer, you will have different limitation. But it's not like, LNG export is not like that. It will change every day. So let's say Qatar will have a long-term contract with France. Let's say contract for 20 years, 30 years, 10 years to export LNG to France. Okay, so that means Qatar will design his LNG treatment plant for the next 20 years to produce the LNG that is required by France. Okay, because changing any of this, it means a huge amount of change in the process. So Qatar has his specific customers for a long-term contract. It's not 1 day or 2 days. Okay, so here in this table also, this table is very important. Typical LNG product specification. So you might have some questions from this table. That the minimum amount, okay, the maximum level of each of this component in LNG. Typical value is this values that you have here. Okay, so typical values. So this is important. And okay, quality adjustment of LNG. You saw one example of UK, that the LNG that UK is receiving is too rich, is very pure. So they will mix it with nitrogen. So this means the adjustment of the quality of LNG based on the need of that customer. So how we can adjust the quality? Enrich of LNG by adding LPG. We can add liquid petroleum gas to adjust. This is one of the ways that we add LPG. You had that table that shows what is LPG, the the major molecules. Blending LNG with natural gas, okay, or using with natural gas itself, because LNG and natural gas, they have different components. When we condense the natural gas, we remove some of the components. So natural gas, as it is arrived, in the pipeline, can be different from LNG, right? So, or we might have LNG that we receive from different countries with different composition. We can blend these LNGs and have the LNG properties that we need. Or mixing with some inert gas like nitrogen. This is what's happening in UK. Or or extracting C3 plus or even ethane C2 fraction from LNG by fractionation. Okay, so because LNG contains these molecules, is not only CO2, it's not only methane. It can have this component as well. So that means we can remove these molecules C3 plus or even ethane C2 to adjust the quality of LNG based on what we need. Okay, here we have a summary. We are almost done with this unit. So natural gas is as a summary is important step. Natural gas is a very clean fuel and with less impact on the environment, considering with other fossil fuels or like gasoline. It's a clean fuel. Liquefaction is required for storage, first of all, transportation, and also to respond to the pipeline gas supply during the peak. So during the peak demand, we can adjust our demand. We can respond to the demand by using LNG and injecting to the pipeline. So purification and quality adjustment is a very important step. Why? Because we need to have the gas specification based on the need of our customer, protect the equipment of corrosive corrosion and some other phenomena, and also environmental reasons. Okay, and how we can adjust it? Based on the we can change, we can play with VI, Wobbe Number, Wobbe Index, and also interchangeability parameters, let's say mixing the natural gas with some nitrogen, inert gas, LPG, and so on. So here you have some additional information. This is a table that is one sample of the table that EASEE will publish, let's say every year, that shows what's the minimum and maximum of each of this specification in natural gas. They update these values continuously based on the regulations, environmental regulations, safety regulations that they have. This is just one example. Here, okay, some conversion. There is another table that we can use to convert HHW to Wobbe number, heating value to Wobbe index, based on the density of the gas, based on different factors. Okay, it's just conversion factor from HHV to Wobbe Index or vice versa. Also, water containing natural gas, there are some, for now you don't need to know these three tables, you don't need to memorize them. You don't need to memorize them, but this table is important. Okay, you might have some question from this table, from these numbers here. And water content based on the temperature and also operating pressure, or the operating pressure and temperature, we can calculate the water content of natural gas. Okay, so this curve only is used to find that parameter. And finally, okay, that's all for this unit. Hope you enjoy it, and I'm gonna upload unit 2 and other units as well. You have also a link here, useful link, that you can have some information about the LNG process. There are also many videos on YouTube. If you are interested, you can just search and watch. So thank you. That was all for today.